Is mine? Yeah. Okay. Are you on?
Yes. Hello, Tom.
Hello, Val. How are you doing?
How are you doing?
I'm very good. How are you?
I'm doing fine. Fancy, thank you.
Is that an English accent?
It is, yes.
That's a shocking English accent. Welcome to the session. This is, in case you needed to know, hopefully you're in the right place. It's blockchain, and then the clickbait title of what is it and how do you use it to become a millionaire? First question, who thought they'd be a millionaire by the time they leave this session? Some disappointed.
Well, you can too if you follow Tom's every instruction. So let's look at these results.
Oh, the cloud's gone. There it is. Okay. There's always one. Bitcoin's a massive answer. Responsibility is another big one.
Umicore is one.
I like Silk Road. Whoever added that one, that's good. Best we don't discuss that. So quite a lot of variation in what we think about when we think about Bitcoin and blockchain. And then most people in the room stay away from it. Hopefully we can change that by the end of this session.
But there's about 10% of you are holders.
Is anybody a millionaire in cryptocurrency already and they've just come to laugh at us? Good, that's a good start. Okay.
We actually are millionaires in our own cryptocurrency.
And we'll show you how you can do that by the end of this session.
It may not be worth very much, but...
Okay, so what you're going to learn over the next 90 minutes. The first thing we're going to do is spend a bunch of time level setting on blockchain. So a 101 on the fundamentals of why we're all sat here, why there is a buzz around blockchain in general. Then how it's being used in the industry today, what verticals are using it for what reasons, and whether they should be or not. And then what actually it is. We'll get down to the meat of what blockchain is, how it functions, and an overview of how you do transactions and how they roll up into blocks. And then finally, we'll talk about when you should use it and when you shouldn't use it, or when you could use something else. You don't have to chuck blockchain at everything. Then we'll move on to developing on blockchain. So the first 45 minutes to an hour will be the fundamentals, then we'll get into developing on blockchain. Now, don't freak out when you see some code. We won't keep the code on for long, but we want to show you some code so you can see just how much code you have to write to, say, create your own currency, for example. But we won't keep it on there for long, and we'll talk about the tool chains that go with that so you can deploy some cryptocurrency yourself and create your own tokens and become millionaires 10 minutes after you leave this session. We're going to give you an opportunity to buy some DevNet coin, which we're going to create for you today. And in a process, you can buy some DevNet coin and make me and Val richer, which we like.
It's a great offer.
And then finally, we're going to look at the future of blockchain. Where do we think it's going to go? What do we think is going to happen in the market as we move forward? Will it crush all the markets and destroy society, or will it do nothing and just peter out? And then finally, we'll talk about blockchain at Cisco and what we're doing in that space. Okay, so kicking off on blockchain fundamentals. Hopefully everybody's in. I can't see right to the back, but hopefully you can see the screen, so that's good. Okay, so why is blockchain interesting? Why are we here? So right now we have the World Wide Web. We have the Internet of Information, if you like. And we have the Internet of Things that's being created as we talk. There's a third component that blockchain brings to the table, and that's the Internet of Value, if you like, a way for peer-to-peer communication and payments that take place. It's also a way to provide digital proof that somebody owns something. So it adds that value to it. And this creates, or allows you to create, some cross-industry efficiencies and helps humans along the way. Now, to kind of give you an analogy of that, so it's not just a slide, imagine you are a driver of an electric vehicle. Everybody has range anxiety when they drive an electric vehicle because they might run out of electric and they don't go as far as, say, petrol or diesel right now. So you're worrying about where the next electrical point is that you're going to have to find, and then will it be free or will you have to wait? So it's always constantly on your mind. Then when you get there, you plug it in, and then you have to get out and pay for that, no doubt. And it's all tricky, and humans get a bit anxious about it all. With blockchain technology in there, what could happen is you take your smart car and have them pay for microtransactions on your behalf. So when you're driving along, instead of you having to worry about the range anxiety, Your car could make a call to the Internet of Information, the World Wide Web, to say, where's the nearest free point? Give me the next 2 nearest free points so I can just drive there. And then your car just says, hey, go to one of these 2 points. They're free now. You'll be able to grab some electric really quite quickly. And it will pay a micro payment. Your car on your behalf will pay a micro payment to that information site. And as you drive further, you land, plug in at the station, and then it pays automatically. Your car will pay automatically for that electricity, and you'll drive off. So from a human experience, you did nothing. Your car told you what to do, you drove, you paid, you drive off again. With the ability for your car to pay microtransactions through the Internet of Value, the human in the equation gets a much simpler and nicer process, and the people who offer the information have a new business model. That's one example, and we'll go into a few different verticals as well that kind of blockchains are actually suited for.
I don't know, Tom. It sounds a little bit far-fetched.
That's what they said about space flight, my friend.
Oh, okay. All right.
Okay. So if you haven't noticed, Val is American, which means you'll hear a lot of routers today. I don't know what that means. I think it's a router. I've been trying to work it out. But bear with him.
I'm just here to keep Tom honest. So
just don't bring that English accent out again.
No, I'll
be good.
I'll be American.
Okay. These are some other verticals that blockchain is being applied to right now. So it's not just people immediately think banks, finance. That's what blockchain is. That's what Bitcoin does. That's what cryptocurrency does. But blockchain is actually being applied to other things as well. So enterprises are using it for cross payments between their companies. Obviously, banks use it, or looking to use it to figure out how they don't get left out of the equation and can do, say, country-to-country transfers. Media are using it. So we're seeing streaming music now being paid to the artist via blockchain immediately. So artists have to wait normally a long time to get their cut of a music share when it's sold. Through things like Ujo Music, which is a little app that you can go to, they get paid immediately by downloading that song. So it's cutting out some of the industry, some of that process, creating that cross-industry efficiency again. And public sector is a huge one. Governments are looking at how to do it for IDs, for voting, for things like government and welfare payments as well. I think the UK government overspends $2 billion a year on welfare payments. If you had a system where you would never overpay and you could prove that someone's been paid, then you save yourself that kind of money instantly. And it's all to do with data and security and how that's folded into blockchain and the way it works. And we'll talk about that a little bit later on.
So, Tom, you've painted an amazing picture about the value of what blockchain can do and this utopian world where everything is great. Why do you guys think it hasn't happened yet? Anybody want to volunteer? Just say, what do you think? Like, why all these amazing things that he talked about? What do you think the problem is? Why it hasn't happened yet? Who said that? So he said it's too new, there's no regulation, nobody understands it.
That's just a prize he's got in his hand, it's not sinister. He's not really angry.
Yeah, so, there's a lot of reasons why it probably hasn't taken effect yet. But thank you for volunteering that answer.
It is true. One of the things is it's still very new. There's quite a few implementations, but none have really massively taken hold yet.
And quite disruptive to a lot of people that are frankly in power, that don't want to relinquish that power.
Incredibly so.
So let's go to a little quiz here. Satoshi Nakamoto, oh, sorry, sir. Great response.
Yeah.
So he said, because of security, there's a lot of things being hacked. Now, I'm giving you a smaller present, not because I don't think you're any less of a person than he is. It's just he was first and brave. So.
But that, again, is true.
Could you pass that to him? That's my game. I completely agree with you.
It is. So hacking of some of the exchanges you've probably heard, like Mt. Gox, etc., really big issue and gave Bitcoin specifically, as well as blockchain, the underlying technology, a really bad name. So that stops other people wanting to use it when they see people getting hacked and losing
Right.
money.
So let's start in the beginning. Bitcoin starts with this person named Satoshi Nakamoto. Person, group of persons, don't really know exactly who he is. Perhaps he's in the audience with us today, laughing at us.
We'll go back.
So Satoshi began this paper. It came out. Did we do this survey? Just go without it?
Do that first, and then we'll do the survey.
Oh, okay. See if they're paying attention. So on October 31st of 2008, this paper comes out on this forum, released by this person, Satoshi Nakamoto. And he says, I got this reference architecture for how this new peer-to-peer payment system can be done. The paper is actually about 8 pages long. It's pretty easy to read, actually. And interesting enough, it doesn't say blockchain once in the paper. So a couple months later, on January 3rd, 2009, about 10 years ago, the first Bitcoin was mined. And since then, a lot of different things have happened. Before 2010, when Mt. Gox was launched, if you wanted to get Bitcoin, you had to either mine it yourself on your computer, and we'll talk about what mining is, or you had to go find somebody who had some and exchange it for cash. So Mt. Gox was this first exchange where you could actually pay them money and then they would give you Bitcoin in exchange for it. Several other exchanges started launching, and then other different takes on Bitcoin started launching, such as Namecoin or Peercoin. All of them had slightly different ways that they were doing the way that value was transferred. And then in 2013, this young kid, Vitalik, comes out with this idea for making a distributed, decentralized computing platform called Ethereum. And he puts his paper out and gets millions of dollars of people just saying, oh yeah, I think that's a great idea. And finally, Ethereum launches. In 2016, 2017, we saw just a lot of interest from different organizations, lots of VC firms coming in. And one thing that was really interesting is we saw that different communities start to disagree with each other. For example, there was a lot of people that thought that Bitcoin should increase the block size so that they could get more transactions, whereas other people thought that's not a good idea. So the community disagreed. And so on August 2017, I guess July 31st, I went to bed that night, and I had some Bitcoin. And then I woke up the next morning, and now I had another kind of Bitcoin because it had forked.
Free money.
So it was like free money. And so I asked my wife, I said, do you mind if I take this free money that just appeared out of nowhere and buy a Bitcoin miner? She's like, it's your imaginary money. Go ahead and do what you want. So I bought an S-Mine Ant miner. So it was really interesting. And those forks have kept coming. There's been several different forks of the original Bitcoin protocol.
Okay. And, oh, sorry, buddy.
Nope. Lots of forks. Lots of acquisitions.
Has anybody heard of Mt. Gox? Testing people's memories, a few folks. So that was the first Bitcoin exchange, as Val said. They accidentally misplaced 450 million worth of Bitcoin and got a bit of a bad name after that, so they collapsed. But that's the first initiator for kind of blockchain getting a bad rep in the early days. Not to do with blockchain, but actually it was the code that was written on the blockchain, and it's an interesting differentiation to make. So, you can get your mobiles out again. Let's see who's been paying attention while we've been chatting there. What year did Satoshi Nakamoto publish his paper on blockchain? 34 people have already had a go.
It's 32.
Oh,
35.
2 people decided they didn't want to answer after they did.
So
I've got to find my mouse again now.
you're so close.
Where was I? It's impossible.
Oh, you're over to the left. Go to the right.
I'm going to the right. Oh, I'm going.
I think we probably missed the speaker training on this part of the...
There we go.
Okay, people listened.
Solid. Well done.
Great job.
I could give you all some chocolates. I would. But I don't have that many chocolates. Okay, so that's why we're all here. So how are blockchains being used today?
And the first one, of course, is Bitcoin. All the rest of them have been shoot-offs of it. As people started understanding this whole concept of Bitcoin, they started realizing that this is solving a very hard problem of how do we get different people who don't trust each other to agree and to settle on something that is actually written down that we can understand.
Now, Bitcoin blockchain, or the blockchain that Bitcoin sits on, so if you can imagine Bitcoin being an application on a blockchain, that blockchain that Bitcoin uses isn't the only blockchain out there now. There are a lot of other blockchains, all with different code bases. One of them is Ethereum, the one that was crowdfunded for 18 million. This one's interesting because it has something called smart contracts, which we'll talk about a little bit more later, and it allows Turing-complete code with loops, etc. in it, to be deployed onto the blockchain, and then you can call that code and execute code on other people's behalf, so you can start to build applications on the blockchain.
So Turing complete, that's just a fancy way of saying the coding language can do while loops and for loops.
We like to put Turing on the slide because it makes us sound like we know what we're talking about. There we go, but it's just loops in code. This is a slide on all the other kind of verticals and examples of them, of where blockchain or cryptocurrency is being used today. So I'll call a couple out. Healthcare there, DocChain. They put people's healthcare records on blockchains. Reason why they do that is, at least in the UK, it's not necessarily the case, you would think it would be, but it's not necessarily the case that all the hospitals talk to each other. They all have their own databases. So if you walk in one, they might not have the same records as somebody who walks in another. DocChain are looking to change that by underpinning it with one blockchain, one ledger, one set of data, and then your records are stored on that blockchain. We have social media there, Kik. Kik is like an application for teenagers. Millions and millions of teenagers on Kik. They use it to create a coin that you can then purchase things with inside their application. And then, of course, if you've got a lot of, I think they call it kin, their token, and then they can use that, obviously, to buy things within the actual game. So they're tying dollars, euros, pounds back to kin and making money that way. And then you've got other strange examples like Electron, energy-wise. They're allowing people to buy energy off their neighbors. So you would have, if you've got solar panels on your house and you're over-generating electricity, instead of selling it back to the grid, you sell it back to your neighbor for cheaper, and then it doesn't have to go all the way back to the grid, it goes back to a point of presence, and they're generating money that way off a blockchain. Some really interesting kind of ways of Bitcoin.
And I think a lot of these are just in their early stages. They're just getting started, so you probably haven't heard of a lot of these before. And who knows whether they'll be around.
Exactly, yeah. And finally, I'll probably touch on IoT, because that's a marriage made in heaven, to be honest. Like blockchain and IoT, like Internet of Things, like smart devices, talking to each other without humans involved, swapping currency on humans' behalf is kind of a way to really create better processes and efficiencies in the businesses and the processes that we have today. Okay, so that was some advocacy around what they do and why we're here. Now, how does it actually work? Let's get down to the meat of what a blockchain is and how do they work. Okay, so after all that hype, what's a blockchain? Well, it's just a database. But it's a database, a transactional database with some interesting qualities. So imagine that we're all in a blockchain. Let's call it the Cisco Live blockchain, and we're all taking part in that. If we were doing that, everyone in this room would have a full copy of that database to be able to transact on it. So you can't put a transaction into a blockchain, you can't add data unless you have a full copy of that blockchain. No one entity controls it. So not one person can rewrite the blockchain. It's essentially free and wild once a blockchain starts. So anybody can, in theory, no one owns it, anybody can transact on it, but no one can then change those transactions. And then finally, it's cryptographically secure. There's tons of mathematics behind this stuff, and it relies heavily on cryptography to run and be safe and very, very secure. It's a trustless network, a trustless system. Now, when I say trustless network at Cisco, people start running around trying to hit me.
With routers?
with routers?
Yes, routers, routers.
Good man, I'm impressed. I'll shake your hand. Well done. Learning slowly. So, so trustless in crypto world is really good in blockchain world, because it means you don't have to trust everybody else in this room to know that your transaction is valid, to know that everyone else's transactions is valid. And that's the key property. I don't have to trust anybody, yet the system works. You just can't trust anybody these days.
No.
Okay, so transactions. When you put a transaction into the blockchain, it gets put into a block and then added to the chain. And we'll talk a bit about more of that in just a second. But transactions into blocks on the chain.
Okay, so let's describe this. Like Tom said, there's a lot of different blockchains out there. So we're going to give an example with Bitcoin, since that seems to be the one that we're all much more familiar with. And we'll talk a little bit about how it works. It's very simple. Well, each person has a public key and a private key. And the details of that are a little bit more complicated. But for the most part, there's a person in this photo right here. His name is Alice, and she wants to buy some coffee. And so what she's going to do is she's going to take out her mobile phone. There are various applications that can do this. And she's going to find the address of the coffee shop. A lot of times you can do that with a QR code scanner. And so she'll just open the application. It could be a Coinbase application, which is very popular right now. There's Kraken. There's a whole bunch of other ones, Bread Wallet. And she goes through, and then she says that she finds the public address of the coffee shop. And then she enters the amount that she wants to put in there. And then she hits send, and it goes over out to the blockchain. So here's an example. It's just a peer-to-peer network. And so as many of you may be familiar with peer-to-peer networks, what happened is they just all communicate with the people that they know. They know about their neighbors. It's really just a protocol. And so like a routing protocol, right? And so they understand that they're going to get, they get a transaction, they validate it, is it accurate? Yes, and then they send it on, following the rules of the protocol. And then that just gets broadcast through all the different people in the network. Now, what gets transmitted eventually in these transactions is it gets put into what's called a block. And the block consists of a header and a body, just like an IP packet. The body are all these transactions. So there's certain actors that live on the blockchain that are gathering all this information and trying to form blocks out of it. The header is the part that has the information, just some metadata about the body, and then the body is just transaction. All it has are just the transactions of all the different people that have been sending it back and forth.
And the link to the previous block is kind of the key there, because you're linking blocks together, you're chaining blocks. Block, chain, yeah, good, okay. The other thing is, like, when you create an account, you get two keys. You get a public key, which you keep to yourself. I've just squashed my mic. And then you get a private key. You get a private key which you keep to yourself. Don't give the public key away. You get the private key that you keep to yourself, and then the public key gets distributed to everybody else. So they all know how to contact you, how to give you money, how to pass deeds to you, how to prove that you own something, for example. If you give your public key out by mistake, that's fine, because it's probably not by mistake. They can give you stuff. If you give your private key out, they'll just rob all the money in your account. Never give your private key away. Just a hint and a tip there.
Similarly, if you lose your private key, you no longer have access to any of your funds. And so this is one reason that a lot of people have, it's estimated, I think, like 25 to 30% of, even more than that, of the Bitcoins have been lost because of people lost their keys.
And they'll never be retrieved. If you lose your private key, you don't get the money back. Don't lose your private keys, but don't give them away.
Okay, so the people that are putting these blocks together are called miners. Is anybody in the audience here mining today, or were in the past? We have a couple.
Are you rich?
Oh,
the hands go, oh, he's rich. Okay.
What are you guys mining? What are you mining?
Bitcoin?
So a couple of altcoins, Ethereum, and a music coin, you said? It's probably worth a ton of money. Anybody else out there? Very cool. Yeah, so it used to be with Bitcoin, you could just open up your laptop in 2010. If you knew about it, you can just put it up and you get a couple hundred different Bitcoins, and it would be very easy. Nowadays, it's very difficult. So the reason why is because of, we'll talk a little bit about the mathematics behind it in just a second, And it'll be fun. And then, but the reason why is because we have to race all these other people. And so it's very difficult to get that number that we'll talk about here. But like I said before, I bought one of these miners, and you can buy multiple miners from different vendors, but they just have special ASICs on them that make it so that they can mine very quickly and do this one thing really well. Okay, so where are we? What happened there to our slide? Okay, so here's the difficult part about it. This is why it's so difficult to do this. And so I'm going to explain this. It may take me a little bit of time, but we're going to go for this, okay? You all know mathematics. So if I say y equals x squared, and I say y is equal to 4, what is x? Minus 2 or 2. We've got to give these things out. Good job getting -2.
Basically, Val's got too much chocolate. He's giving it away.
It's imported from Castel de Fels. Okay, so that's called a two-way function. If you know the answer, you can probably find somehow easy the input to it. You can find x, right? But there exists inside of mathematics a set of functions known as one-way functions. And a one-way function is a function such that if I give you y, the answer, it might take you millions of years to find out what x is. And it might be next to impossible to find. And so a lot of cryptography is based on this concept of a one-way function. What we do is we take some input and run it through this function. In this case, it's a hashing function. And then it gives us some random output that we would never know. But one property about these functions that is great is that if I give you x and y, you can very, very quickly determine that x does indeed equal y. So even though it's difficult to guess what x is, it's easy to verify. And so this makes it very easy to verify what is happening. So what happens in Bitcoin is we take all these transactions together and we put them in a block. And then we run all of these transactions through a one-way function. After we have that one-way function, this is called a Merkle tree, we'll have one single hash value. It's like a 32-bit address, okay? 32-bit number. We just put it in the header. Now, we take the hash of the previous block and put that in the header as well. And then we put the timestamp so everybody knows. And now we've created this block. Now what we want to do with this header is we want to run that through yet another one-way function. And when we run it through this one-way function, we want it to be that it reaches a number that is less than what is known as the target number in Bitcoin. Okay? Now, I mentioned all those things in the header that you can see, the block of the hash, the Merkle tree, the timestamp. So we run that through there, but it's going to give us some random number. So what we need to do is we need to make it less than some value. So we have this attribute inside of the header, which is called the nonce. And the nonce, we can change. We can make that any number we want. And so what is happening with these Bitcoin miners is they are taking these blocks, and all they're doing is changing the nonces and running it through the hash and seeing if it gives them a value, in this case, that begins with about 18 zeros to get that target number. And that target number difficulty changes over time. So the nonce is just a way to make sure, is the only thing that we can change after we've created the block. Okay?
I think it's, what's the chances of guessing this one-way function right are something like 10 to the power of 20 in Bitcoin or something like that. So they've got to try that many times. That's why you need an incredible amount of CPU energy to actually mine a block, because it's incredibly difficult guesswork. Well, it's just guesswork effectively, but on a massive scale. Now,
why do you want to mine? The reason is because every time you mine, you get to create, in this case, it's about 7.5 Bitcoins you get to earn by mining one block. So people are incentivized not to cheat, but to actually mine the Bitcoin. And so then you get the money, and then there's also transaction fees that you get as well. So this is why people are incentivized to join mining pools. Like you may have heard people joining mining pools, because it's a winner-take-all. But if we have a pool, and we collectively put all our machines together, and all our machines are guessing different nonces, then we have a better chance of winning the block before somebody else does.
Cool. Okay, so that was hardcore. That's about as in-depth as we get. So we thought we'd ask a question at this point, just to shake off the cobwebs. What is the nonce used for in the block header? Let's see if we get some correct answers. Some people might just look at us and go, we've got a plucky one person so far. Okay.
By the time you actually get it working, we might have like another 100 people on it.
Look, he's gone again. The mouse keeps running off. Can you spot it?
Oh, there it is.
Oh yeah, there we go.
Click. Hey!
Ah.
Thank you for those who voted.
Nicely done. That's correct. It's a random value.
Oh, you can't change your answers afterwards.
Yes, change the answer. If I knew who that was, I would actually give them.
I would take their chocolate.
Yeah. Anybody change their answer to the correct one after we? Oh, it's a shame. I want to give you a scarf or something useful. Okay, we're gonna stop. You're my favorite audience from now on. That's brilliant. Okay.
Oh, okay. Now people are changing to the wrong answers.
Okay.
All right. So once you get the block and you have it, so remember we're racing against a bunch of other people, right? Yes, sir. The question is mining necessary to maintain the system? Well, yes. And the reason being is because one of the values of Bitcoin, which differs from a lot of the other things, is that usually when there's some type of money being exchanged or some type of value being exchanged, there's some type of governing organization. And in this case, with Bitcoin, it's power to the people. The people are the ones that are deciding. And so by mining, that is how they're all verifying the transactions. And so in the case of Bitcoin, if there were no mining and we didn't waste all this electricity and destroy the planet like what's happening right now, then we wouldn't be able to have that happen. So
yeah.
Thank you for your question.
Yeah, it's essentially the way that you the blockchain is, or the Bitcoin blockchain specifically, is stopped to be hacked by using proof of work, because it's a very hard thing to do. If you didn't have that, people would just be chucking transactions in and validate them themselves, and you get lots of double spend. Because everybody would be just going, yeah, there's $20 for that, that's a valid transaction. They'd sign it themselves, and then that would just be valid. You wouldn't be able to trust anybody. With the proof of work mechanism, it was really, really difficult to actually validate a transaction. You have to have mining rigs to do it, so it protects the network. And you have to have 51% control of all the miners in the network to be able to actually attack it. No one's ever had 51% of the miners in Bitcoin. If you do get 51%, then you could start double spending, but you would need like half the data centers on the planet to do that, so it's pretty secure. Okay, so that's some of the maths behind it. Now, how does that consensus work? So we talked about proof of work there. That's one consensus method. That's one way that we all agree in our Cisco Live blockchain that we're all a part of, that all the transactions are valid, because the miners have come to a conclusion of a valid block. Then all the miners agree, yes, that's valid, I can work that out. Good, that transaction gets put into the blockchain. That's an incredibly intensive way of figuring out consensus between us all using proof of work. And there are other ways to do it. They have their good points and they have their bad points, and I'll take you through those now. So proof of work, it's great because it's really secure, but it takes there's anonymity, so you don't know who the miners are, but it's hugely intensive and takes a lot of time. So on the Bitcoin network, I think it's a block every 10 minutes or something. 10 minutes. So that's like, it's quite slow. It's okay for swapping the odd Bitcoin, but you couldn't have an exchange on there for like a real-time exchange on there. It's too slow. So there are other mechanisms, and you see these here on these types, and I'll go through each one. So the next one is proof of stake. Ethereum's actually moved into proof of stake. It used to be proof of work. And proof of stake is a mechanism where if you have, say, you have to put so much of your cryptocurrency into the miner, and then there's a lottery algorithm that the blockchain has inbuilt into it that chooses the next miner to validate a block. If it chooses you, you get to validate that block, and then you get a reward for doing so. The likelihood of it choosing you is dependent upon the amount of stake that you put into that miner. So if Val puts 10 Valtoms into a miner, and then I put 100 in, that lottery algorithm is 10 times more likely to choose me to mine the next block than Val. So I've got 10 times more money coming towards me.
I know what you're saying. The rich get richer, poor get poorer.
You got it.
This is like an oligarchy thing.
So that's great from a proof of stake because that's far less intensive. And if you then decide to put a bad transaction in the block and it gets pushed out by the rest of the miners, you lose your stake. So it's very important that you're either willing to lose your stake and be naughty, or you just validate valid transactions. The bad thing about that is Val's point. The bad thing about proof of stake is it's a more centralized system. The people with more money are more likely to mine and get rewarded for doing it. Pluses and minuses. To get around the shortfall of proof of stake, there's delegated proof of stake. Delegated proof of stake is where Val has a miner with 100 tokens in there and he's mining away. I've got 10. I'm sad. I only get 10 times, Val's getting 10 times the money as me. So I choose the 10 people on this front row to mine with me, and we delegate a miner on our behalf. We've all got 10 tokens. We pool them. We get 110 tokens. We're now more likely to get chosen to transact on the next block than Val. So it's a way of evening that field. We would then split the rewards between us, but we still get some of the rewards. So it's still a more centralized system than, say, proof of work, but it's better than proof of stake in terms of centralization. And the final one is a real mouthful. Practical Byzantine fault tolerance. You have to try that in front of the mirror.
Rolls off the tongue.
And this is to do with the miners are known and they pass messages to each other, anonymous messages to each other. These technologies, these maths behind that, which I won't go into, it's too much for today. But basically they can, through passing gossip to each other about the state of each miner and what transactions they have and they don't have, they can find out what are the valid transactions and what are the bad transactions. This again is great because it's very low in terms of intensity on CPU. It's very quick, but it comes at the cost of anonymity. Everybody knows who the miners are, and only those miners are getting paid. Now you can see here the different types of systems that run on those. Hyperledger, Stellar, Ripple, these are types of blockchain. Different blockchains to Bitcoins, different blockchains to Ethereums. These are different blockchains again. So these are different methods to reach consensus, but they're all very secure and they all provide the same function of a blockchain. Yes, sir? If you own half of all the tokens, the question was, what if I own half of all the tokens? In proof of stake, in the world of proof of stake, I guess? You could crush the network. And that's the short answer, is you would actually have power in that network. And that's why when they do proof of stake, they generally push a lot of coins out to a lot of people to begin with and then push the coins into the blockchain slowly. So somebody just doesn't go, I'm having half of that and then control the whole thing.
Like you'll see with our cryptocurrency here in a few.
Yeah, like we've done on ours. We own that. But ours isn't proof of stake. Okay. So right now what we've been talking about in our Cisco Live blockchain is a public blockchain. There are different types. So the first one is public. We're all in a public blockchain and anybody can join that. It's non-permission. No one owns it. So we can all join, we can all leave, and that's called a public blockchain. Ethereum is a public blockchain. Bitcoin is a public blockchain. But then there are different types. There are permission types, private and community. And a private blockchain is something where there's permissions associated with it. So maybe only this side of my room can be in my blockchain session blockchain. You guys are still in the Cisco Live one, but we got special blockchain over here. And then you've got special blockchain called It's Worth More blockchain on that side. These are private blockchains because people choose who can actually join them. So again, more centralized in a system that only allows some people to join. But when you're in there, it's actually a decentralized system just for those folks. And community is the same kind of thing as private, except for you might choose, say, 5 companies that are working together in a blockchain. So you might get 5 banks that decide to have their own blockchain, and then only those 5 banks use that blockchain to swap money. and the other banks aren't in that consortium. And there are reasons for that. Like, I might not want to see every single, like if I'm a bank, I don't want to see all the public. I can't allow my public people to see all the transactions that are going through my bank. I can't allow them to see all the other banks that are seeing my data. So I need a private one that only the people in my community can see the transactions going backwards and forwards. And these are much more, I would say there's a lot more private and community blockchains in circulation than there are public at the moment. Blockchain types. So there are also a concept of side chains. So in the 1970s, there was lots of networks, and they were all sporadic, and they were all split up, and every company had their own network. And along came the internet and joined them all together. We've got the same kind of concept in blockchain at the moment. We've got lots of different blockchains appearing. They all don't talk to each other. I can't put Bitcoin through Ethereum. It's actually BTC Relay have just been looking at this to try and figure out how to do that. I can't put one cryptocurrency through another blockchain. It doesn't work like that. And the concept of sidechains is people are building connectors between these blockchains to allow you to start talking from one blockchain to another. And effectively, you're creating larger blockchains. But right now, they're called sidechains, where you push some crypto from one to another block.
Like a blockchain router.
Yeah, like a router or blockchain, yes. Okay.
Okay. One aspect of the blockchain that we're particularly interested in is the smart contracts. So smart contracts, as the name tries to imply, is that it's something that's smart and it's a contract. In truth, what it is it's code or state that lives on top of the blockchain. So for example, I can put something on the blockchain that says Tom equals 3. For whatever reason I would want to do that, I don't know. But I would say Tom equals 3, and I would want that state to be kept inside of the blockchain. Mm-hmm. Or I could say Tom owns this property at this, address or this location on the globe. And that is something that would maintain, so that state would be in there. And then we could make rules about how that could change. For example, if Tom and I both agreed on a time and we both gave our keys in there, we could then execute that to change it over to somebody else, so they might become the owner. And so smart contracts are really just how do we create like the state and have variables on the blockchain and how that can be changed.
Yep. It's just code. If anybody's familiar with Oracle stored procedures, you'll know this. It's code stored on a database, effectively. And then you can call it via different methods, like I want to explicitly call it.
Or triggers when something happens.
Exactly, that's right. I want to call it, or I want a timed event to call it, or it might be on a certain date like Christmas. We all get an extra Bitcoin, and I execute that contract, and it all sends an extra bit of currency to you guys because I'm nice and I like you to celebrate Christmas. That allows you to build applications. So what you have then is a database or a data record, which is your blockchain. You have smart contracts, code stored on that blockchain, and then you could write an application at the top that then calls those smart contracts. And what you're effectively building there is an indestructible application. Because anyone in our Cisco Live blockchain could execute the code that I've written and deployed. You would execute that when you mine the block. You'd get a reward for it, and then my application would run because you're executing my code for me. If half of this team then left the blockchain, this other half would still be executing my code. So I could have like a ton of failures in my nodes, and I'd still have a running application.
And we're being a little bit vague here about where these distributed applications run, because they can run on Hyperledger, they can run on Ethereum, they can even run on Cisco's blockchain. So there's different platforms in which they can run on it. So you can see this is pretty early stuff still. A lot of you guys were around when the internet was starting and Ethernet started to win out. And you might see some similarities with that as we start developing more and we see things start getting done.
Yeah, and as blockchain technology improves as well and gets faster, this will become more of a reality, I think. With a 10-minute block mining time, I'm not waiting 10 minutes for some of my code to execute. So I wouldn't write one on, say, Bitcoin blockchain, for example. So there are definitely limitations to this. And just to touch on distributed applications. So
the thing about different applications as developers write them, you ever seen Star Wars where he says only a Sith Lord thinks in black and white, It's not that way. It's a spectrum of different ways that applications can be written. So some applications, such as iTunes, is completely centralized. There's this governing body, the benevolent dictator of Apple, that is making sure that you pay that money for the music. And then it starts going to Napster, and then BitTorrent, and then this free-for-all, and then over here with Ujo Music, which is actually on the blockchain. So there's different ways that applications can be written. And so distributed applications that we write may have some aspects of it that might be on the blockchain, but the other of it might be on something like Amazon.
Yeah. And at the end bit, the Ujo Music, they're required to be obviously no servers, no central servers. That's a blockchain. We're all executing code, even on our laptops, if that's where you downloaded the blockchain. Okay.
Oh, this is my favorite part. Tom, tell us when we should use a blockchain.
Okay, all right. So now we know the why, the how, and the what.
And there will be a quiz at the end of this one.
Now we need to know when. So I've had the opportunity. I'm quite fairly lucky to be on a couple of boards, and on that they and a couple of government incubators as well. And part of that, a lot of people have come up to me and said, "Hey, I'm going to use blockchain for this special thing I've got, this new use case." And my answer at first, I was like quite energized by it, but then I became a kind of a pessimistic evangelist for it. And my first question out of my mouth every time is, so you want to use a blockchain, huh? And then I'd have to figure out their actual use case and why or when should they use a blockchain, or when they might consider something else, like a database that's already out there. So I actually built an applicative framework that people can kind of use to figure out whether they want to use a blockchain. It doesn't stop you using the blockchain, but you might want to think about using something else, for example.
But there's only one question. Do you need a database?
To begin with, this slide builds out magically. So the first question to ask yourselves.
This slide really looks like it's going to start building out. This slide really looks like it's going to start building out.
I hope it does, because it's a really boring slide. Okay, so the first question to ask yourself is, do I need a database? If you're writing an application, chances are 95% of the time you're going to need to store some data somewhere. So much of the time the answer is going to be yes, but if you're just writing a front end or something else, a pass-through, you might not actually need to store any data whatsoever. If you don't need to store data or transactions, you don't need a blockchain. The next thing to ask yourself is, okay, right, I need a database, I need to store data.
So then you need a blockchain?
Not yet, no, not yet. You might, but ask yourself this question first, Val.
Okay.
Ask yourself this. Do you need shared write access to that database? So if there's only you writing to that database, or only you need to write to that database, chances are you're going to be overkill using a blockchain. You don't need to use blockchain. You can trust yourself. Hopefully you can trust yourself to write the right data to a database. So if you don't need shared write access, you don't need a blockchain. You could use a database.
But if you do, then you need a blockchain.
Well, I'd kind of ask yourself this question first. Do you trust all the writers? Are they all known, and do you trust them all? So I need a database. I need more than one person to write to it. Do I trust everybody? Can I trust all the other writers? Can I trust all you to write to the database accurately and not cheat? Yes, I think I can. Generally trustworthy faces in this audience. Are our interests unified, though? So I might be able to trust you all. Like I trust Val. Val's a friend. Are our interests aligned? Well, I support Manchester United, greatest football team in the world. Val doesn't. So in that way, our interests aren't aligned. So we might be adding data to the database for different purposes. Though we trust each other in the real world, the data we're adding to a database might be for different reasons. So if your writers' interests are unified, though, and you trust them, and you're all pushing in the same direction, then again, you might not need a blockchain. You could just use a database. It doesn't stop you using a blockchain. You might want to just use a blockchain for fun. But if you're a startup and you're on limited resource, you might want to just use a blockchain, use a database rather than a blockchain. You've got a bigger pool of people, more skilled people outside of the blockchain space right now to aim at. If the answer to those two are both no,
then you need a blockchain. Okay. there's one other question.
I'd ask yourself one more question.
Just one more?
Because I'm running out of slides, so I know this is my last question.
Okay.
Do we need to use a trusted third party? So, I could use a blockchain for, like, cars in the UK, for example. We have to tax them. We have to tax them. It costs me money. And then we put that information on a database. And when we pay, the database gets updated and said, yep, we're not going to take care of you. You've been taxed. It's great. Okay. If I was to build a blockchain-based version of that, so everybody puts their money into the blockchain, it tells us that they've been validated, police don't come and take my car away, it's really good. It wouldn't matter. I have to use the government-sanctioned database for the tax. I could build the best blockchain system in the world for car tax. I still have to use the UK's government version. In that case, if you have to use something that already exists, don't use blockchain, use what already exists, because you're writing it for no reason otherwise. Okay.
If not, then you use a blockchain.
Yes. Now the question becomes...
Oh my gosh, another slide that builds out the questions.
Now the question becomes, at this point, you've got a good case for blockchain, actually. So I need a database. I don't trust anybody in the world. And there's nothing out there that already does what I want. I've got a good case for a blockchain here. Do I need to control the functionality of that blockchain? Do I want to write my own code? No, I don't. I'm going to use something that already exists. Thank you very much. Do the transactions, are they public or private? Do I care about my transactions being public or private? If I'm happy for everybody to see the transactions that I'm making,
now I'm using a blockchain.
Then you're using a public blockchain. So at this point, you could use any of the public blockchains that already exist, like Ethereum or Bitcoin, for example. But you probably want to write your own application code, so you need something with smart contracts, so Ethereum's a good one for that.
I feel like I need another long chart to tell me now which blockchain should I use.
I'm glad you think that, because that's what we've got. Do you need to control the functionality? Well, yes, I actually do. I actually need to write my own code base. Everything out there at the moment in this space doesn't have what I need from a blockchain, so I'm actually going to add some code to something that might be open source or write from scratch. Or, if you don't want to see every transaction that's being put through, like a bank, then you might want to use something more private. And the final question.
Yes, we can use a blockchain now.
Yes, you can use a blockchain.
Yes.
Oh. Where do you want the consensus?
Where is consensus determined?
You're not paying attention, pal.
Intra-firm, yes, then I want to use a blockchain.
Unbelievable. So, if the consensus is if you want one organization to come to the consensus, say, take the 5-bank example again. If you want just one bank to be able to confirm your consensus and you're happy with that, use a private blockchain. But if you want all 5 banks to have some say in that consensus to say what is valid and what's not in those transactions, it's better to use a community blockchain. Now, that was a whole world taking of it.
That was very complicated.
I've got a sweat on from
I think the answer is, if your friend comes and says, do I need a blockchain? You just say no. You just use a database. Or have them talk to Tom.
Now,
the question is, what's the question again?
The question is, are open source blockchains like on GitHub community blockchains? They could be community blockchains, but they're more likely to be, they could be any blockchain actually, because it's just code in GitHub. So GitHub's like for folks that don't know, it actually just stores a code base and then you can deploy it where you want. If you chose to deploy it to anybody and have no permissions on it, then it would be a public blockchain, anybody could join it.
Yeah, but
if you deployed it with permissions to say, I'm going to deploy this, but I'm only going to let 10 people in this room join, then you have a private blockchain. Or if we've got 4 companies in this room, and they were allowed to join, we'd have a community blockchain. You're using the same code base, but for different purposes.
And Bitcoin actually hosts all kinds of different blockchains, including Bitcoin is actually on GitHub, and so is Ethereum, and so is Hyperledger. So all the different chains are on there. But how they're used dictates what if it's community or open.
Yeah. Okay, so that's the why, the how, the what, and the when in 55 minutes.
Yeah.
Okay. So now we're going to ask you a question off of that flow chart, so I hope you're all paying minute attention. See what you think of this. Your friend wants to use a blockchain to replace Uber. Is this a good use case for blockchain?
Should we play the darkness music?
Play that game, play that game. You see it?
2 responses so far.
I can't see. Can I? Where is it? Where is it? There it is.
I see the mouse.
All right. The results coming in, and I've found my mouse, which is useful.
Let's click. You're getting good at that.
All right, I'll leave it for a little second longer, because I know you're all going to change your answers once I show this.
So, Tom, I'm worried. You know, the people came here to know how to make money to be millionaires, right? And so we showed them how it works. So we better start getting to show them how to make their money.
Have a look at, we will. Let's have a look at these. This is quite an interesting spread, actually.
Yeah.
So we have, this is brilliant, actually, because this is what blockchain actually does to people. It completely splits their point of view depending on where they're coming from, whether they think it's a good idea or not.
Even Tom and I disagreed to some extent.
It was a brilliant question because we spent about 10 minutes arguing over the answer.
And of course, I was right, but Tom disagreed. All right, so let's eliminate what isn't correct here. So first of all, let's go with B. Has anybody ever thought of using blockchain for Uber before? Don't be shy. Nobody's ever thought about using a blockchain for Uber before? Certainly that might have crossed your mind. Okay, well, it happened to cross my mind, and I know it's happened to about like 10 billion other people. So that was probably wrong. However, so the answer is probably people have thought of that idea before, so absolutely might be more of a maybe.
And I was on more of an A trend where I would go, well, no. Uber controls Uber, and they all trust each other to write to their database in their application. So why do they need a blockchain if they trust their own writers?
But I say maybe, because depending on how you use it, it might be better to have a decentralized system. For example, here in Barcelona, where we're arguing over taxi fares and they had a strike, maybe this could be a way to solve that and keep it here locally, right?
Right.
So there's possibilities, but difficult. So.
And then we had a big English-American argument over it, and then we decided, you're all right, no worries. Okay, so, but it's interesting that split and how that occurs.
Yeah.
Even from the same information that we all have. Now, that's great. So now you know, was there in that C, hello, sir.
Yes.
So the very good call out there is that if there was a community-based Uber where all the money went into a pool of taxi drivers, then that would actually be a great case for a blockchain. And actually, that's a bad idea.
And I absolutely agree with you on that. And this is where people get excited about Bitcoin, or sorry, the blockchain and how it can be implemented, especially as you see these big companies getting larger by taking money from local places like Barcelona here, right? So.
Okay, cool. So.
Thank you.
Yeah, thank you for that. In fact, there's chocolates on the line.
Let's give him the Milk Sublime. This is imported from Castel de Fels.
Excellent choice, Val.
About 20 minutes away.
Connoisseur.
So, thank you.
Okay, so for the next half an hour or so, we're going to talk about actually how you can become a millionaire. So now you know all the technology behind it, how it's being applied, when you think you should use it. Now we're going to give you the tools to actually be able to go and apply it. And in the same breath, become millionaires and then thank us by giving us some of your money.
I think we should say, too, that my life hasn't really changed all that much since I've been a millionaire in my own cryptocurrency. But I hope that as you use these tools, you'll use them responsibly.
I own 5 cars, 25 houses, swimming pools. It's brilliant. Love it.
They're all digital.
I wish, yeah. So Ethereum. So we're going to use, everything that you're going to see us do right now is on Ethereum. It's just a choice that we made because it's actually quite popular now and there's a lot of tools around there that we can quickly show you. We're just going to show you some tools that we've used. There's many more out there. We won't get too technical. We'll show you some code, but as I say, don't freak out. It'll just give you a feel for how you actually code, deploy, and then use some of the techniques and the smart contracts that we talked about today, so you can see it in action. Then you can take that away and actually play with it in a website we've created to actually get hands-on yourself. So, creating smart contracts. So we're going to talk about standards, tools, talk about tools, that'd be wrong. Standards, tools, and tool chains. So, to do that, we're going to create our own token today.
Today is the launch, ladies and gentlemen. Thank you for coming.
The great DevNet ICO. You're welcome.
That we did last year in 2018.
Yeah, we have many of these coins now. And an ICO is an initial coin offering. It's a way of generating money for an organization to use to actually expand. The ICO is going to look like this. In a minute, we're going to create our own token. When we do that, we're going to create 20 million of them. Instantly, Val and I will become millionaires because we're going to give each other 5 million of them. The other 10 million will be there for you guys to buy. You are so lucky, so lucky.
Today only.
No, today only. Does this sound like a good ICO to you guys?
What?
Where's all the yeses? So, yes, it does if you're me and Val, specifically.
We each get 5 million of our own cryptocurrency. That's a pretty cool thing.
And we're going to build this token to a standard, and it's called an ERC20 standard, and it's an Ethereum standard of writing a contract. We're beginning to see standards created in contracts. Originally, it was like the Wild West, and people would build these contracts and then deploy them, and then people would abuse them because there were massive holes in them all the time, or couldn't use them properly to get the money back out of. It was chaos. So they started building standards around them so other people can interact in the right ways with these smart contracts. To do that, we need to give our coin a symbol. So we're going to give it the DEV symbol. These are all three-letter acronyms, so DEV we've chosen. Okay, now, so that's what we're going to build, and this is what we're going to see. Now, to use that, to write a contract and deploy it, there are three main things you have to think about. You're going to have to write it, then you have to deploy it, and then you're going to have to think about what platform you're going to deploy it onto. So the first bit is writing them. The two, you can do this in a number of ways, and again, there are a number of different tools. The two that we're going to look at is Remix and Parity. Remix is actually an in-browser editor. It's like an IDE. It's quite cool. You going to show that one today?
I will, yeah, absolutely, Tom.
Very nice. And then deploying it, we're going to use Truffle and these other ones like MyEtherWallet. I love MyEtherWallet because it stops you getting phished. There's so many spin-offs of these sites that are looking to try and get you to put your private key in. You have to be so careful. And MyEtherWallet's really good with MetaMask, and MetaMask will tell you, it's a plugin for Chrome, and that will tell you if you go to a bad site, it'll say, you're about to get phished. Don't do that. It's really quite useful. And then finally, the platform we're going to choose is Ethereum, but it has test platforms. So there's test public platforms that have fake currency on it too, which is fantastic for what we're going to do today, because otherwise we'd be throwing live money around. You'd actually be paying us in live money. That would suck. We don't actually want your money. We just want you to buy the tokens to get the feel of how you do it. So we're going to use a Kovan network, which is an Ethereum test network, but it runs exactly the same as Ethereum with the same proof of work behind it. Putting those tools into a chain, you get something like this. So there's different types of chains you could put together. There's a UI-based and a command line-based here. This UI will be then Remix, MetaMask, and the Kovan network, and you could probably do that for your browser. But I'm more old school. I would use command line because that's a bit more fun for me. I would use Atom. Val's a bit more older school than me, so he uses VI.
It's true.
Jeez. And then Truffle, everybody who uses VI now is looking at me going, you're an idiot. But I use Atom, Val uses VI. Truffle is a command line tool for deploying it, which we'll be quickly showing you too, and then that'll get deployed on a Kovan network. So we're going to follow this command line kind of deployment, and Val's going to take you through this step by step in the next 5 or 10 minutes. The language that they're written in is something called Solidity. Solidity is a smart contract language that's not just on Ethereum, but used in a lot of different blockchains. So it's actually like, I wouldn't say de facto just yet, but it's probably one of the most popular languages for writing smart contracts in. For the developers among us, it's like JavaScript, if you like. Okay, take me through. The first thing we're going to do is show you a smart contract. If you would take me through a smart contract, Val.
Okay, you want to get money, this is what you got to do, okay? So the first thing you're going to do is you're going to pull out your Solidity browser. Like a lot of these millennial kids, they're like doing everything over the They develop the tools in JavaScript. So that's what we got here with Remix. You can go to the website, it's remix.ethereum.org. You're going to have to find the ERC20 standard, which Tom talked about. Once you have that, you're going to see that there's about 6 different functions that you have to define inside of your contract. And the contract is just basically the way that money is going to be doled out to people. It can be done through time. It can be done through different actors. And in our case, we did it through a couple actors. So I'll show you. So this part right here of the contract shows that it's an ERC20 interface. So it's almost like, this may look familiar to a lot of you if you've done any coding before. And then we have right here, which is the main part of our contract, which is the DevNet coin, which is an ERC20 interface. To make this a little bit more clear, I'm going to switch to VI because I find it easier to read because it has my cool color-coded
Pretty
things.
colors, yes.
Yeah, so, okay, so over here is the code for the contract. Let's just analyze a couple points of it. I don't want to bore you too much, but I want you to understand just a couple things. The first one is this function right here on line 74. This is what is called the constructor. And in the constructor, we're dictating how the coin is started when we deploy it. So the coin requires 2 addresses to be started, and these 2 addresses are in Ethereum. One of the addresses I named Val. The other one I named Tom. And so what we did is we put our addresses in. We create 20 million coins right here, and then we immediately give 500 million, what was it? 5 million to Tom and 5 million to me. And then there's some that is left. So that is what this function does right here. Now, we want people to be able to buy it. So what happens is if they buy it, they call this function. So once the contract's deployed, it's going to create an address that lives on the blockchain. Now what can happen, like any other address on the blockchain, you can send money to it. So when you send money to this contract, what it's going to do is it's going to call this BuyDev contract. This BuyDev function. And what the BuyDev function is going to do, it's going to do some awesome math, and then it's going to say, you know what, our contract is so good for you guys because if you give me 1 Ethereum, I'm going to give you 100 DevNet coins.
That's a bargain.
That is like a bargain.
Bargain.
And then what I'm going to do with that Ethereum that you gave to the contract, I'm going to split it up between Tom and I. So Tom's going to get half of your Ethereum and I get the other half. But in exchange, you get DevNet coin. That's a pretty good bargain.
Right.
Now the last function I want to show you is what happens if I kill this contract. Well, what happens if I kill the contract is that if there's money left over in it, it has to go somewhere. And it can only be 1 address that it goes to.
What?
And being that I wrote this, I felt it was only appropriate if Tom doesn't withdraw his funds, that all the money go to me. So I think we have a good deal, right, Tom?
No.
That is a contract in Solidity.
Always make sure that your users' goals are aligned. Unbelievable. So I better draw my money out fast because otherwise Val will fleece me. So that's a contract. Now the thing to take away from that as well is like that's how easy it is to do an RC20 contract. On top of that, it was 195 lines of code to create your own token. That's why you see so many tokens being created, because it's that easy to do. Now, so you can all do that. You can all create your own token, and you'll be millionaires. Great, like me. So the next thing, so what you've seen there is a red box. We've created our contract, and then we have inspected it, and then we're going to now deploy it using Truffle. We're going to deploy it onto the test network, as we talked about. If we deployed it onto the live network, number 1, it would cost us money to do it. And number 2, it would cost you money to then interact with that token, that contract, which we don't actually want your real money. We should have a tip jar around here. You can give us tips later, but other than that, we don't actually want your real money. And we can tell you how to get fake money from here. So we won't go through this slide too heavily, but you can get fake money from for the Kovan network simply by going to the faucet and asking for it, and they'll give you some to play with. You can have your slides afterwards. So. On that note, could you please deploy your contracts?
Not so fast, Tom. Now the problem here is if I deploy a contract without testing it, I can lose a lot of money. So what I'm going to do is I'm going to use the Kovan network like Tom explained. So that doesn't cost me any money because I need to get some funds first. I'll show you how to get that in a second, but I'm going to use a test network that's available for you. Also what I'm going to do is I'm going to write some tests for my code because I want it to work. So for example, here's some of my tests. If I try to give money, when the DevNet coin is created, it's got to make sure it actually puts money into Tom and my account. So I have this little testing function that does that. If somebody tries to buy the DevNet coin, I got to make sure that it actually gives it to Tom and I. There's been a lot of hacks on these smart contracts. Tell them about the DAO.
The DAO, has anybody heard of the DAO? So the DAO was a massive smart contract that people would add money to, and then they build this big pot and fund startups off of it. So the DAO was this big entity that would then feed other entities and build startups. But they built their smart contract in a way that it was like going up to a bank teller and saying, can I have some money? And the bank teller would go, yeah, here's $500, that's what you asked for. And you could go, great, I'm just going to sign that off. And then before he could sign it off, he'd go, can I have $500? And you go, yeah, okay, here's $500. And before he could sign that again, he would ask for 500 more. And he would just keep doing that until he absolutely drained the millions that was in this smart contract. And that was just a loophole in the smart contract that was used by the DAO, by a hacker, from what they saw in the smart contract code of the DAO. So you have to be very careful when you're writing these smart contracts. And that's why standards exist. Because
it was so much money, it actually caused the Ethereum blockchain to fork. There's Ethereum Classic, which happened when the guy actually exploited it, and Ethereum, which is the main Ethereum one right now that you hear about, that they're using after reversing the effects of that exploitation.
Right.
Okay, so to deploy this, I'm going to use Truffle. I've already tested it. Now I run this Truffle migrate, and what it's going to do is it's going to run this great command that's going to push it out to the blockchain and migrate it out. So let's see what happens when I run Truffle migrate on the network, which is Covan.
Let's check that the network is up to date.
Okay. I think that. I have my notes because we want to reset it. I think I just give it like a reset flag on this.
Hard reset. And that should go away and deploy our contract. Now what you'll see is some verbose feed out, I would imagine.
Okay, so what is happening here is it's just going through, and in Truffle it actually creates a smart contract to actually do the migration. But you can see that as you deploy a contract out on the mainnet, it actually costs money. So in this case, there's this idea of gas, which is, and then there's the gas price. And gas is just a unit that eventually transfers to Ether, but it tells you how much it actually costs to use the network. None of this costs me any money because I'm using the Covan network, but it takes away some of my fake money. So you can see here, so it put the deployments on here. So here's the transaction. This is the one that it's in. So this is being gathered by the blocks and put into the blocks. And you can see this fun little red thing right here. So it's very serious that it's doing it.
That is pretty cool. Now it's going away and placing.
So now it's saving the migration to the chain. And here's the actual address that it deployed. So it deployed the contract. By creating it, it gives it its new address. So this is the address. And I can actually go to the Covan online. There's this website called etherscan.io. And you can actually search for different contracts that are in here. And you can see that, oh, this one still is so new, it hasn't been created yet. So in a couple of minutes, it'll actually show up.
Yeah, the reason why it costs you to put your smart contracts onto a network is because when they execute, if you put an infinite loop in there, then whoever tries to execute that contract will be trying to execute it forever. So you have to add some money to it to say it will cost this much to execute these contracts, and I'll give you that tiny little micro payment. And that way, if it runs out before the code finishes executing, everything gets reversed. But if it executes to the end, then the person gets that tiny little bit of money and your code executes. And it's a way of stopping infinite loops being crushed.
Okay, so this contract has been created. Now we created this before actually, so it lives somewhere else. But it's identical to the one that we actually deployed. And this is actually called DevNet Coin. So you can go to devnetcoin.com, and we'll give you instructions on how today, and today only, you can buy some of this DevNet with some fake money. So you can get fake money by actually using fake money to buy fake money.
It's a lot of fake money, but we're still millionaires in fake money. So what you've seen there is Truffle deploy our new contract. And when we deploy that new contract, it gives us the public ID of that contract. A contract gets an account just like a person would. So it gets this public ID that's then pushed out onto the network. You can then use that public ID to interact with that contract. So you've seen us create the ICO, you create that contract. As soon as that happened, I became a millionaire.
You're amazing.
You became a millionaire. Again, loaded. And then from there, we then go and want to inspect it. So Etherscan's really good that Val was just showing you there, because we've shown you some code and a command line, but how do we know it actually exists on the network? And that's where Etherscan and MetaMask come in, because you can actually see that contract, how much is in there, how much has been given to who, and all the transactions that have been executed on that contract since it was first instantiated. Are you letting them see inside the chain?
Let's just go and show them how to actually buy this. All right, so we showed you a little bit about Etherscan IO. And we're going to introduce you to one of our favorite tools on the web, which is called MetaMask, or just MetaMask. And so MetaMask is a browser extension. And you can see right here that I have some money. In fact, you may be saying, I'm flossing, I'm like flaunting my wealth right here. Or flexing, I think is the word the kids are using, I'm flexing. So right here I'm showing you that I got $1,788, right?
Yeah.
Well, it's fake 100, so because this is using the Covan test network. So this is money that you can get as well. So if you want this money, what you do is you just go to this guy's website right here, and all the instructions are on devnetcoin.com. Again, that's devnetcoin.com, buy now. You can go here, and you can just enter in your address of your own wallet. So you download MetaMask, you create your wallet on myetherwallet.com. I'll copy this in here, and then I'll put my address in here.
Is that your private key?
Oh, yeah, no, it's actually my public one. So I put that on there, and this nice guy who has an automated framework is called the Faucet Network. He's going to actually give me some of this test ether that I can use. So he gives me about 3 ether every several days. He might actually say, you know what, you already asked for some 2 days ago, so I'm not going to give you any more. But that's how it works. Greedy. And then money just shows up right here, and then you can go through and buy. Now, we've tried to make it very simple for you to buy DevNet coin. Once you get MetaMask and it works, our website will tell you that it actually works. And then what you're going to do, you get the test ether, and then you just simply press this button to buy DevNet coin. You can see down here that there's a number of people who have bought DevNet coin. They took advantage of our special offer. And here's my address right here. I am actually the king of DevNet coin right now. Sorry, Tom.
I hate that you have 600.
I'm about to buy one more DevNet coin.
I hate this.
So I run the MetaMask thing here. It comes up. It's only going to cost me $1. I mean, that is just ridiculously cheap. So I say confirm, and it's going to go through and just buy some DevNet coin for me. It'll update, and pretty soon you'll see that my tokens actually show even more. So when I wrote this, we didn't write a lot of the different checks in there that we would do in some type of production thing, because we just wanted to show a demo. But pretty soon it'll just show up and say, OK. That's all you get to know, is that it actually went through. So
you can follow these instructions in your own time afterwards. Let's say it's just devnetcoin.com, and hopefully that will give you the information you need to run these transactions yourself, as well as an example of the code to run to do it. So that's really good.
So those are the tools, Tom. We showed them how to do it. That's how you make that money.
Yeah. Okay, so that's like, we're millionaires now, and it's 10 million for you to buy. That was really cool, but obviously it's fake money for fake money for fake money. So in the real world, when somebody deploys a coin, how do they actually make value out of it? There are a number of different ways that you can do that. The first one is exchanges. Leo Coin's a really good example of this. So I met the founder and I asked him, like, how did you generate money from Leo Coin to begin with? And he said, well, we created this token, Leo Coin, but all we did then was create an exchange to go with it. We built an exchange from scratch and then tied it to Bitcoin. As soon as you tie it to Bitcoin, Bitcoin is tied to dollars. Dollars is real world. So you've then got a chain of real money back to what Leo Coin is worth. And if Leo Coin's only worth 2 cents for every Bitcoin, then that's great. It's still got a value. If you hold enough of it, you make money from nowhere.
The other thing we could do, Tom, is we have a couple of DevNet scarves. I can say, this is worth 1 DevNet coin. That's the only way you can buy it. All of a sudden, DevNet coin has value.
There you go.
Or you can go to the DevNet zone and get it for free.
Real world tangible benefit. Then the next is like a platform utility coin, and I talked about this with Kik. They've created kin, so kids can actually buy things in their application. And if you buy something with it in the application, like a rucksack or a computer, then you have to have so many kin, and you have to buy that using real-world money. Therefore, kin has value because you buy it with real-world money. And if you created that coin and kept some back for yourself, you've got instant money in your account too. Very clever. And the last is ICOs. So this is the biggest way of making money from coins, is to actually say, right, as a company, I really want to grow. And instead of doing like a funding round or offering shares out, you offer ICO. You generate, say, 50 million tokens and then say, hey, these are up for sale. They're about $10 each. People give you money for those coins, and if your business is successful, you then pay them back. So that's another way of just creating money from nothing. Okay, looking ahead. Two things to think about when we're looking ahead. The first one, I don't want to blow your minds too heavily because you've already taken a lot in the last 90 minutes. Well, 80 minutes. DAGs. So blockchain version 1 was Bitcoin. Blockchain version 2 was smart contract enabled. What's coming up next is something called DAGs, directed acyclic graphs. These are effectively, instead of having blocks, you just have transactions, and a minor transaction is a different mechanism completely, which I won't go into, but these actually these DAGs allow far more throughput of transaction validation than the traditional blockchains that we see today. These have like thousands upon thousands of transactions being validated every second. So at that point, things like Visa payment solutions become viable on a blockchain. Things like applications, distributed applications, become viable on a blockchain using DAG technology. And you can see 3 examples that I've put there of DAG technology actually in action. Hedera, Byteball, and IOTA use this DAG method, and I'm seeing more and more spring up all the time. So to me, that's kind of like the next generation of blockchain. I don't know if it will ever take over blockchain. I don't think it will. I think blockchains are great for cryptocurrency, but I think DAGs might be the platform for applications that are built on blockchains. So that's the middle one of these. Sorry. So that's the middle one here. And then the 2 others become IoT and blockchain. They're a marriage made in heaven, as we've talked about. Paying for things on your behalf without you in the equation really does make the world a better place for humans and creates new business models for business owners out there. And I'm hoping in time that blockchain becomes like TCP/IP. It exists, it's super useful, people use it all the time, but they don't know it. They just use it as the internet works. And I'm hoping that blockchain evolves to that kind of area with these new DAGs, for example. 2 things to watch out for are governance. When you just produce a new coin all the time, governance is very hot on things like, hey, you can't just create new coins. If you try and push a blockchain solution out there that's unregulated, the regulators in that country will come down heavily on you. If you don't release closely with regulators, bad things happen. You have to keep regulators of each country that you want to produce a solution in close. And if you don't do that, bad things happen. Look at Uber when it goes into a new country, it changes the business model, and then you get strikes. And it's the same with blockchain technologies. That's disruptive. Unless you're right next to the governance people, problems will occur. And then the final thing is smart contract practices, which are negative as well. We talked about the DAO. If you don't write that code well, if you don't test it, bad things will happen. And I think that's true in any form of hardware and software. If you don't write it well, then somebody will abuse it. Okay, so what is Cisco doing in this space? There are 2 main things. We are part of the Trusted IoT Alliance, IoT and blockchain, marriage made in heaven. And we're looking at things like how we can generate new models in the Internet of Things, create reference architectures with our customers and partners, standardize how blockchain works with IoT, and really move into the open source space. So anything that we think works and generated will be provided into the open source community. And there's a number of different companies in the Alliance. And we're actually also deploying our own Cisco blockchain, which we've built, which is a permissioned-based blockchain. Certain verticals we're aiming at right now. That's in EFT with some customers, and that will be released further as we move through the year. If you want to get hands-on with blockchain yourself and actually build your own blockchain and create a blockchain and actually play with it a little bit and have an open source version, head over to DevNet Sandbox. You can click on the Hyperledger Fabric tile, and that will spin you up a blockchain yourself, a private permissioned one. Hyperledger is an open source blockchain, and you can go in there, play around. There's some like learning labs that go with it, so you can play and get hands on there as well as DevNet Coin to figure out how you add transactions to it. Continue your learning.
Buy DevNet Coin.
That's how continue your learning is live. Go buy DevNet Coin and you'll learn all you know. On that note, there's a Teams obviously for this session, so you can go to Cisco WebEx Teams, hit us up on there. We'll continue the conversation. Happy to answer any of your questions. Please do complete your surveys online. I'm sure you've heard that once or twice this week, but please do that. The feedback is really, really useful to us. Thank you very much. You have been a wonderful audience, and thanks for answering our questions as well as providing your own.
Thank you.